Okay, so elimination method. This is the third one. Usually this is good and useful to use if both equations are in what we call standard form. This is usually the easier method to use. And standard form, I'm just going to jot it down under what I wrote there. It's basically you're going to have x and y on the same side, then it'll be equal to a number. So the general form for standard form is ax plus by equals c. The numbers would be filled in for a, b, and c. They have to be integers, so it would look something like that. That's usually the fastest method. You can change them to be solved for a variable or something if you want to use substitution or graphing, but usually if they're in this format, elimination is a little bit faster. Okay, to actually solve a system, if you guys look down here, these are all equations that are both in standard form in these systems. What you want to do is you're looking for opposite, and I just mean like one's positive and one's negative, opposite coefficients on the same variable. That's what you're looking for. That would be the easiest possible situation you could have. If you're looking at the homework paper, the very first one has something like this, but opposite coefficients on the same variable. If you want a little example, maybe like 5x in one equation and negative 5x in the other equation. Okay, if you don't have that, you may have to create this, and to do so, all you're going to do is multiply 1, or sometimes, depends on the question, both lines to create that. All right, and then once you have opposite coefficients, all you're going to do is add the two lines in your system, and that'll eliminate whichever variable has opposite coefficients. Okay, so what I would have you look at first, if you have a system, like I have in example 1 here. All right, so I have 4x plus y equals 0 and 4x plus 2y equals 20. I don't have opposite, like one positive and one negative coefficient in any part of that. Both of the x's are 4, so that could work in our favor. Does anybody know what you might do here if you were trying to create opposite coefficients? What would I maybe multiply by to create that situation so I could just eliminate a variable? Yeah. Yeah. Okay. Now, in this case, these are both 4. If I add these together, that would be 8x. That's why I want to introduce a negative here. So it doesn't matter which one, just run a -1 through every single thing in one of the equations. I'm just going to run it through the bottom line. You really could do this to the top if you wanted to. Okay, I'm just going to copy the top one real quick. So just keep it 4x plus y equals 0. The bottom line, if I multiply everybody by -1, it's just going to take and make each sign opposite. So it's be -4x minus 2y, and then just don't forget it has to be by everything, including the 20 that's on the other side of the equal sign. That would be -20. That equation is equivalent to the one that was originally typed there. We're just manipulating it for our purposes. Okay, now for elimination, once you got opposite coefficients, I have a +4, -4. If I add the bottom line to the top line, that cancels this variable out, which is the whole goal. And then you just have to go through the rest of the problem. So 1y plus a -2y, it's literally just like 1 minus 2. So this would be -y, and then 0 plus a -20 is just the same as 0 minus 20. And so I'm going to end up with a negative on both sides. And to get your y all by itself, all you got to do, divide by -1, you're done. Y is going to be 20 there. And then this is like the problems we were doing on Friday. I really only have half of my answer there because I'm trying to figure out the point these two lines have in common. So I have the y coordinate. So how do I find the x coordinate? Plug it in. Now, honestly, you can plug it into literally any one of these equations that we have just written. I usually go back to the original system and pick one of the ones with the smaller I would probably just plug it into the first one. So just make sure you plug it in for the correct variable. So we found y, so I'd do 4x plus y. In place of the y, you can put the 20. And then we just solve this real quick. I'd subtract 20. So I get 4x is negative 20. What's my x going to be? Negative 5. And then if you just, as long as you tell me x and y were good, if you want to write it as a coordinate point, the x coordinate would go first and the y coordinate would go second. So that intersect at the point negative 520 on a graph. Okay. Anybody have a question? All right. Now, you'll notice all these numbers that are my coefficients here. I've got a negative 2, a negative 7, a 15, and a 5. They're all different. So I can't just run a negative through. So what I would recommend there's different ways to solve this, but just recommend, look at the two x's. Okay, am I multiplying 2 by anything to get 7? Not unless you want to work with a fraction, I wouldn't recommend that. Am I multiplying 5 by anything to get 15? 3. Okay, would you use a negative 3 or a positive 3? Okay, I would use the negative. Okay, so just try and look for something for yourself that you could multiply 5 by 3, get 15. These are both positive, so I would just say, let's just make a negative 3. That way we'll have opposites on those y's and we can eliminate that variable. So I'm just going to copy the top line. Negative 2x plus 15y equals negative 32. Okay, now just be real careful because it's easy to forget one of the parts, but to keep and make this an equivalent equation, you have to make sure every single thing gets multiplied by negative 3. And so that'll cancel out some of the negative signs on this problem. So negative 3 times negative 7 is going to give you positive 21. Negative times a negative. Negative 3 times this 5y is going to give us negative 15y, which that's what we want. That's going to give me opposites on my my y's for my coefficients. And then negative 3 times negative 17 is 51. And of course you guys can use a calculator if you want to. Now, if I have opposite coefficients, I can just add the bottom line to the top line. For the x's, negative 2 and 21 is going to give you 19. 15 and negative 15, they eliminate each other. So that's our whole goal, is to eliminate a variable. So we got rid of the y there. And then negative 32, add that to 51. Actually, that gives you 19. What would x be there then? 1, yeah. Okay, so x is just 1. If you divide 19 by 19, you're just going to get 1. Okay, again, very much up to you, whichever one you want to use. You can plug this into any one of the equations in the system. I usually try to pick one with maybe the smaller coefficients just so it's less work. I don't know. So I'm going to plug it into that second line in the original problem. It's negative 7 times x. I'm just going to put my x value in there, which is 1, plus 5y equals negative 17. So I got negative 7 plus 5y, negative 17. I'm going to add 7. I got 5y is negative 10. And then I'm just going to divide by 5. So y would just end up being negative 2. And if you, as long as you got x and y, you're good. If you want to write it as a point, the point those two lines would intersect in would be 1, negative 2. Okay, anybody have any question? That's if we just multiply one of the equations. We kept the other one the same. All right, now, this is the worst case scenario you could run into in one of these problems. This is example 3. All right, I'm trying to get opposite coefficients on the same letter. So like a positive 2 and a negative 2 or something like that. So in this one, am I going to multiply 2 by anything to get 3? Am I going to multiply 4 by anything to get 5? Unless you want to work with a decimal, no. What do I have to do? Does anybody remember? What do you have to do in this situation where neither one, like I have to do something, it can't just be multiplying one of the equations. What do I have to do here? Both of them, right? Okay, what variable do you want to go after? X or Y? Doesn't matter, but X. Okay, how would you do it? Like what would you multiply by? You got to multiply both lines. Yeah, definite. Perfect. Okay. So you gotta just, he said he wanted to make X be the one we eliminated. You could do this for Y also. It's totally up to you. One's not easier than the other, or I would tell you. But literally, if you have to multiply both lines, you just take the coefficient from the first equation, just put it down here. So like here I'd have 2 times 3, that's going to give me 6. Here, take the coefficient from the bottom, move it up to the top, 2 times 3, that's going to give you 6. Now, doesn't matter which one, but I want to try to create opposite coefficients, so one's positive, one's negative, doesn't matter. I'm just going to run a negative with the 2. Okay, that way I'll have a positive 6 on the top and a negative 6 on the bottom. You just got to be real careful here because you're going to have to do a lot of multiplication. So everybody in the top row, I'm going to multiply by 3. So I got 6x plus, what is that, 12y, and then 3 times negative 4 is negative 12. Okay, now I'm going to run a negative 2 through everybody in the second row. This is going to allow us to get rid of our x's. So negative 2 times 3 is going to give us negative 6x. Negative 2 times 5 is going to give you negative 10y. And negative 2 times negative 3, negative times negative is going to become positive. So this will be 6. Now, the whole goal there, we got opposite coefficients on the x's. So if I add the bottom line to the top line, that eliminates x. And we just then have y. So 12 plus a negative 10, or it's like 12 minus 10, you have 2y. Negative 12 plus 6 is actually negative 6. Divide by 2, and then we got our y coordinate, which should be negative 3. Now, you have 4 different options for where you can plug this back in to get x. You can pick any of them. I usually pick one of the equations. I'm just going to use the very first one in the original system, just because usually the numbers are smaller to work with. Just make sure you plug it in for the correct variable. So we found y, so make sure you plug it in for y. So I'm just going to write it so you guys can see that first equation. So I'm going to do 2x plus 4 times negative 3 equals negative 4. And I'm just going to solve this. So I got 2x minus 12 equals negative 4. I'm going to add the 12. So I got 2x is equal to 8. And then I'm running out of space because I'm writing too big, sorry. X is just going to be 4. And again, as long as you have x and y, we're good. I'm going to write the 0.43. That'll be the coordinate where those intersect, if you want to write it that way. Does anybody have a question? Okay. Now, on the back, I'm just going to show you what this looks like if you end up with the variables all getting eliminated. So like a special case, like a no solution or an infinite solution. All right. So if I look at this first system, I have negative 3x plus 5y equals 6, and I have 6x minus 10y equals 0. If you're looking at that, what maybe, just raise your hand and tell me, what would you do to maybe eliminate one of the variables there? Yeah, what do you think?
Multiply the top one by 2.
Okay, let's multiply the top one by 2. Okay, I'm just going to write this underneath. So I'm going to run a 2 through everybody in the top line. What would that give me? What would you write?
Oh, negative 6x plus negative 10y equals negative 12.
Did you want to run a negative 2 or positive 2? Yeah, okay, so just don't change the signs here. Okay, wait, the numbers you said were perfect, just not the negative. So like 2 times 5, this would be 10, and 2 times 6, this would be 12. Okay, now, I'm literally just copying the line that was underneath that. I'm not doing anything, that's just the second equation that was in the system. The weird part here, and I didn't need to introduce a negative, because if you were going after the x, just doing a 2 would cause those two to be opposites. And it just so happens the y's are opposites here too. So both variables get eliminated. Okay, so what would the left side of that equation add up to? 0, right? Okay, negative 6 and 6, 0. Negative 10 and 10, 0. So this side does have a value, it's just 0. They eliminate each other, but you have 0 left on that side. Now, that's only important because you got to decide which type of system you have. If they all eliminate, you're going to have to answer whether this question is true or not. So I'm going to get 12 plus 0, that would be 12. True or false? False. No, this doesn't work. Okay, so not true is going to mean to you no solution. Now, if you needed to, if you graphed these guys, these two lines would be parallel in the coordinate plane if you put them together on a graph, but just my answer to the question, there's no solution, but visually these would be parallel lines. Okay. Now, if I gave you this other system here, I got negative 2x plus 3y equals 13, and I've got 4x minus 6y equals negative 26. What might you do to try and eliminate a variable in that second system in that example at the top? Would you multiply the top line? Would you multiply the bottom line? Would you multiply both of them? What would you do? Just raise your hand and tell me. What do you think? Oh. Top by 2. Okay. Again, we don't need a negative. If she does that right, 2 times negative 2 would be negative 4, so those x's would be opposites. Okay, so we're just going to multiply the top by 2. All right, so I get negative 4x. Just make sure everybody gets a 2. And then it'd be plus 6y, and 13 times 2 is 26. Okay, I'm not multiplying anything. I'm literally just coming down here, and I'm just copying that second line underneath. Now, this is super similar to the one we just looked at, but it is going to be different. If I add the bottom line to the top line, the x's are opposites. Negative 4 and 4 add up to 0. The y's are also opposites. 6 and negative 6 adds up to 0, but that's important. That side, everything cancels out, but it's still there. It's 0. And what am I going to get if I add 26 and negative 26? 0. Okay, is that true? For sure, yes. Okay, now, if it is true, what that means is this is going to be your infinite solutions. And if you are doing elimination and this happens, it will always be in this situation where you have infinite solutions, it'll be 0 equals 0. If you have a no solution, it'll be 0 equals some number. Okay, so that's true, infinite solutions. What that means is that these two equations were really the same line. It doesn't look like it necessarily, but those are algebraically equivalent. Okay, does anybody have a question? Okay, I'm going to set up a couple word problems here for you. These are going to be, actually you could probably use substitution on these if you wanted to, but the intention is to use elimination. So that's what I'm going to have you guys try to use today. Okay, the first one just says, Mike has a jar of coins in his kitchen with only nickels and dimes. Completely believable scenario. Okay, has a total of 42 coins, and the value of the coins in the jar is $6.45. Find out how many of each coin is in the jar. Just so we all have the same thing, just for my variables here, what I'm going to do, I'm going to let D stand for dimes and Q stand for quarters. Now, these problems I always feel like can be tricky for people because they almost try to blend the two equations together into one. So we want to make sure we don't do that. Okay, here's the two really important pieces of information. You have 42 coins. Nothing to do with their monetary value. Just, I have 42 coins. Like if I blindfolded you, jumped out the jar, and you counted the coins. You have no idea how much they're worth, but you have 42 coins. D is going to be the number of dimes, Q is going to be the number of quarters. So if I have 42 total coins, how could I write that the dimes and quarters, if I put them together, would give me 42 coins? How could I write that as an equation? Just 42 coins, only dimes and quarters. Don't think about how much they're worth. Exactly. All right, just dimes plus quarters, just number of dimes plus number of quarters, nothing to do with their monetary value, is 42. Okay, now, the second equation is going to deal with the monetary value. So I have the value in the jar being $6.45. How would you write that if you know you're only working with dimes and quarters? So think about how much a dime is worth and how much a quarter is worth. What would that second equation look like if you got $6.45? Okay, did you get rid of the decimal? Like you did, like 600? You can do it. No, that's fine. Okay, so he said 10D plus 25Q. Okay, if you want to do this, you can. But what should the number on this side be? It has to be 645. Okay, if you were like, what the heck, where did that come from? All right, the other way you could write this equation, if you want to deal with the decimals, you could do 0.10 for every dime, 0.25 for every quarter, and then it would be 645. If you do want to work with just the nice integer numbers, you are more than welcome to do that. It just scooches the decimal place over, in each case, 2 spots. So like, here we go, that became 10, this became 25, but then you do have to scooch that decimal place over 2 spots there, and that becomes 645. So if you want to eliminate, that's actually probably a faster way to do it. Okay, so you could do either one. Now, these are awesome because it's super easy to get an elimination situation. If you have a coefficient, like the coefficient of each of those is just 1. So all I'm going to do, you can use the 10, you can use the 25, it doesn't matter. What I'm going to do, and I'm not going to use that color, I'm just going to run, let me just do a negative 10. I'll eliminate the dimes. You could do the same thing, do negative 25 and eliminate the quarters. We would just solve for different variables first, but we should still get the same answer. So if I want to do that, this would be negative 10D, and it would also be negative 10Q, and then I'd have to do negative 10 times that 42, so that would be negative 420. All right, if you want to work with the decimals, the only difference, it'd be 0.10D, 0.10Q, and then 4.20 instead of the 420. But if you don't want to work with the decimal, that's fine with me. Just multiply everything by 100 and you're good. Okay, get rid of the dimes. Those are opposites. 25 plus a negative 10, 15 times your number of quarters, and then 645 minus 420, 225. This is a nice number. Does anybody know what 225 divided by 15 is? It's 15. It's a perfect square if you knew that, but 15 times 15 is 225. So you've got 15 quarters. Now, in this particular case, I would tell you it's easier to plug the quarters back into the very first equation we wrote down, just the dimes plus quarters equals 42. If you know you got 42 coins, just do 42 minus 15, and that means I've got to have 27 dimes. And these are super easy to check if you want to, obviously those two add up to 42, but if I want to do 25 cents times my number of quarters and do 10 cents times my number of dimes, and that gives me the $6.45 that were in the jar, they're very easy to plug them back in and check your answer. If you get a question like this with dimes and quarters, remember you couldn't have we could not have a decimal or a fraction here. It has to be a whole number, and it should be a positive number too. Okay, I got one more. This is a little different setup. Now, this one says, Hope went to the store and bought 5 apples, 3 bananas, and paid $6.50. Then it says, Grace goes to the same store. She gets 10 apples, 7 bananas, and the cost there for her is $13.75. So it's 2 separate sentences, and they're each going to give us an equation to set up our system. We got 2 variables. We got apples and bananas, and we're going to find the cost for just one of each. So just so we all have the same thing, let me let A be apples and B represent bananas. Okay. Could anybody translate the 5 apples and 3 bananas for $6.50 into an equation? What would that look like? Go ahead. Perfect. Okay. Just 5 times however many apples, whatever the price is, 3 times whatever the price is for the bananas, and you know you spent $6.50. how could I write the equation for the other girl? She's got 10 apples, 7 bananas, and it's $13.75. What would her equation look like? Go ahead. Perfect. 10A, 7B, 13.75. Okay, now, I look at this. We got 2 unknown variables, so we have to have 2 equations, which we've got, so we can solve. What would you do, or would one variable, would the apples be easier or the bananas be easier if you're looking at this system to solve for? Yeah. Okay, which one, what would you do to solve for it? Perfect. Okay, 3, you're not multiplying by anything nice to get 7, but 5, we could multiply, like she said, by -2. So I'm just going to run a -2 through this top line. That'll give us opposites. Okay, so everybody here, and I'm just going to write it underneath this. You'd get -10A minus 6B, and then 650 times -2 is actually -13. I'll just put the decimal right underneath mine so it's a little bit easier to put together. That gets rid of your apples. And then this is actually really nice for us because we're not even going to have to divide. 7 plus a -6 would just be 1B, so I don't even have to divide. So this is going to give me the cost of the bananas. 13.75 minus 13 means the bananas are going to cost 75 cents. All you got to do to figure out the apples is just plug it back in, either one of the original equations, it doesn't matter, or you can do the one that we just created. I usually put it back into one of the original equations in the system because they're usually smaller coefficients to work with. I'll just plug it into the first one. Just don't forget to plug it in for the correct variable. So we solve for bananas there. So when you put in, make sure you put it next to the 3. And then what was this, 650. Okay, so I've got 5A plus, let me see what that is, 3 times 75 cents. This is 2.25, 650. I'm going to subtract the 2.25 here. Whoa, I don't know why I just put an equal sign. All right, 650 minus 2.25 is the number. Okay, I got 5A is equal to 425, and then we're just going to divide by 5. This is money, so this is the cost for an apple. And so it's totally okay if it's a decimal here. This is going to be 0.85. So that means apples are each 85 cents and bananas are each 75 cents. Is anybody having a question? Okay. All the questions on the homework assignment for this